Hi everyone, welcome to another video. This is Sam, and this is the second video in the 3 video series that we're putting together for Sysdig. And basically in the first video we talked about CI/CD pipelines, how to use Sysdig Secure to make sure that your developers are following best practices in applying principles of security ahead of time and early on in the pipeline. And if they don't follow these practices, then Sysdig will fail their builds and they can find out what's going on in the very beginning. If you missed that video, there will be a link in the description to go and take a look at that video. But in today's video, this is the second part, the second video, the second demo. We're going to take a look at the second piece. The first piece was building. This second piece is running. So how do you run your containers? How do you run your application? And what do you do in production if something fails? So we're going to be talking about performance, how to monitor this performance, and what to do, what actions to take. So let's dig in. All right. So in the previous video, we talked about build. That's the first step. In this video, we're going to talk about running. Specifically, we'll focus on performance monitoring. We're going to break an application and show you what to look for. So here's the demo number 2. We're going to still use the hipster shop demo app, and we're going to kill or delete the checkout service deployment to introduce performance degradation. You're going to see response time and error rate shoot up, and we're also going to drill into a system capture file to look at the HTTP errors that we see there. Here's a quick overview of what the app looks like inside of Sysdig Monitor. So let's move over to my CLI, and I'm gonna delete this deployment. And if you look at the what pods are running, this is what I'm going to delete, the checkout service. So let's run this command here, ctl delete the service. Let's clear this and run this again. Make sure this is gone. See, it's terminating the checkout service. Okay, perfect. Now let's pivot over to our Sysdig Monitor view, and as you can see here, when you deploy the Sysdig agent, you can deploy it in multiple ways. In this case, you deploy it as a daemon set in a Kubernetes environment. I'm running this app in GKE. And the way I'm looking at this is we're looking at it from a clusters perspective down to the deployments and pods. What that really tells me is, okay, I'm starting at the cluster name level. So I have 2 clusters. And then I see the namespaces inside of each cluster. I got 3 here. I have a deployment name, so I can open up this hipster app and you can see the deployments that are in here, the Kubernetes pod name, and then to container ID, right? So I can continue to drill in to the pod level down to the container level. You can see I have 12 microservices. This is not really a deployment. We show it here for completion. It's actually a pod that I deployed here to show something else. So if I were to go to the last 10 seconds, you can see this goes down because I killed one of the deployments. So if we go to my dashboards, I've created the dashboard ahead of time for this hipster app. And in here, you can see the last, let's say, last minute or so. And I can see my response time starting to shoot up for the application, for the services that I have here, the load generator and the front end, because I have a load generator creating load on that hipster app. If we go over to that hipster app, which I don't know if you've seen this before, but this app is created by Google, and it's really a good app to demonstrate a microservices architecture. It's built on top of 12 microservices. Everything is a microservice in here. The cart is a microservice. The reviews is a different service, and so on. But if we want to go and try this out, let's try to buy this vintage camera lens. Let's add it to the cart. And let's try to place this order. It's going to take a while, and it's going to eventually error out and give you a 500 error, status code 500. So while that does its thing, you can see and notice that our deployments have gone down below the 12 that we expect. So we're down to 11. You already see the event that is fired here. The container is unhealthy. You can see the slowest endpoint is that checkout. I already see 500 status codes showing up for front end and load generator. And while I wait for more alerts to fire, I can show you the topology of my entire application for the entire namespace. So all the different microservices running here, all the different deployments, not only how they're interacting with each other, and in this case I'm drawing this map for volume of traffic between any given two entities. This is more real time. Let's just take a look at the last 10 minutes so it doesn't move too much. So I can see who's talking to who, which is important for an ops team that doesn't know the application very well, but also the ability to see external communication to services that are outside my cluster. And we can show you, for example, if this particular deployment goes out to talk to this IP, right? So from a security point of view, you also want to know where is my application reaching out to and what is it talking to. So let's move back up here. We've collected some data points. So I can see in the last 10 minutes I have a bunch of alerts that I've fired for HTTP 500. Again, I can see the slowest endpoints. So this dashboard is out of the box. Really, I just moved it into my dashboards folder. It's your Kubernetes golden signal specific to a namespace. And from here, we can look at the events that I've fired. I already saw the 500 errors that we saw earlier, and I can see the capture files. I created a capture file for these events. Actually, let me go back to the alert. Here's the HTTP 500 error for the hipster app. So I'm alerting when the HTTP error count goes above 1 in a 1 minute interval. And I'm specifying this for the scope where hipster app is the namespace. This is key because you don't want to flood your ops team with alerts that they might not find useful. So I would scope this to the hipster app, and in my notification channels I would specify that this needs to go to whoever is responsible for this particular application. Now, in the alerts, a unique feature of Sysdig is the ability to create SCAP files, which are system capture files. These SCAP files give you the possibility of looking at all the system calls that are running through the environment in the last 30 minutes that are triggered by that trigger that we have at the top. And the beauty about this is that we can dig really deep and find out root cause for a number of errors that might have happened in the environment. From a security point of view, we use this for forensics as well, to figure out what has happened and if there is a bad actor, what they did inside my environment. So let's take a look. I have a capture that I already created. Actually, our capture probably already fired. Let's see. Here's the SCAP file, and Sysdig Inspect is an open source tool that Sysdig created to give you the ability to analyze system calls. So I see 437,000 system calls in the last 30 seconds. We have 48 HTTP errors. And if you click on any of these tiles, you can see when in time they occurred. So these are created in a, these tiles are organized in columns. So in this case, I'm looking at performance, and I can dig deep into the HTTP errors that I see here. And I don't think we captured it yet, but I do have a capture file all ready to go from before. So you can see my HTTP errors, and here's the 500 error that we're talking about. And you can see the actual entire log that has happened. And if you look deeper here, RPC error code, and it gives you the actual problem. The latest connection error, it's a transport error while dialing TCP with the IP and port, and a timeout occurred. So that's basically what happened, because it's trying to connect to that service, and that service is down. So if I were to copy this and go back in here, and let's clear this out, and let's do a kubectl get services and grep on that particular IP address, we see that this is the checkout service that we just killed. So that kind of gives you an idea of how to troubleshoot, how to dig deeper, go all the way to the actual error log. If we go back to the hipster shop, you typically won't show this error to your customers, but we've captured all that information right into Sysdig, so you can go back and double check. And that pretty much sums up this second demo video. Now you know how to monitor performance of your application, what to look for your Kubernetes golden signals, build a dashboard around it, build alerts, and even in the alert you can create a capture file that's triggered based on that alert and gives you more detailed information when you're running troubleshooting and looking for root cause. Thanks for watching, and I'll catch you in another video.